right, gang, let's work on the next rule, which is the constant multiple rule. So it's basically the same rule we just did, except what we're going to add on is that what this rule is saying is if you have a multiplier on your function, just go ahead and take the derivative of your function as you usually would and carry that multiplier along. That's what it's saying. So I'm just looking at the examples on my paper and I want to just give you an easier one. So let's say that you have a function that is 3x to the 5th, okay? So the 3 is the multiplier that's on it, the constant multiple rule. And so we're going to do this part as we just did in the last section, right? We bring the 5 down in front, we subtract 1. So watch how I do the derivative. I'm going to teach you right away how to do it, combine it right away. If it's too much, you can break it down, but try to combine it right away. So you remember in the past we bring the number down in front, but there's something here already. So I'm going to multiply it. So as I bring the 5 down, it's going to multiply times the 3 because there's something here. So 5 times 3 is 15. And then I'm going to subtract 1 from the 5 to make it a 4. So that's the derivative. If that was confusing to you, I'll break it down. But sometimes when I break it down, that confuses people. So sometimes this doesn't help, but I'll give it a go. So I'll put the 3 outside, and in the box, I'll do the derivative of the x to the 5th. All right, so the derivative of x to the 5th would be 5x to the 4th. Right? The 5 would come down, and you subtract 1 to make a 4. But now all of that is being multiplied by a 3. So that means now you have to multiply the 3 into it and get 15x to the 4th. Okay, so however your brain sees it, just the answer must be 3 times larger than it would have been. That kind of idea. So again, the rule just says take the derivative as usual, carry the constant multiple along. All right, so let's try a couple of these. Let's see how this goes. Now, before I asked you if the variable was in the denominator, I asked you to bring it up. So I'm going to go ahead and do that. So this would be 3x to the minus 1 because I'm bringing the x upstairs. Now I'm going to take the derivative. And by the way, I'm just sticking with the basic notation right now. I showed you all the different types but in 3.1, but I'm just going to stick to this for now. Alright, so just like I showed you before, the power rule says you bring the exponent down in front. So when you bring the negative down in front, it's going to multiply times this guy that's already here. So it's going to make a negative 3. And then you have to subtract 1 from the exponent, right? That's the power rule. So then it's going to become x to the minus 2. And then I asked you just to make sure everything was a positive exponent. So you're going to bring this x squared down. So it's negative 3 over x squared in its final format. All right, let's try another one now. The multiplier here is the 2/5. And the 2/5 is being multiplied times the t squared. You may not have to rewritten this if you saw it clearly. I just wasn't sure, so I rewrote it. Alright, so I'm going to take the derivative of this. Alright, so remember, when you do the power rule, you bring this down in front, but there's something here, so I have to multiply the 2 times 2/5. So I'm multiplying 2 times 2/5, and if you remember, multiplying you go across. So it's 2 times 2 is 4, it's going to end up being 4/5. And then I have to subtract 1 from the exponent, so it becomes 1 less, so that's going to be a t. So it's 4/5 t, you can write it like that, or if you want to put it back the way it came, it would look like that. Both of these forms are correct, one's not better than the other, okay? Alright, with radicals, I asked you to rewrite it in its fractional equivalent. So the root of this is a 2, right? Because it's a square root, so it gets rewritten in its fractional equivalent form like this. So remember, if you have a radical, write it in its fractional equivalent. Alright, let's go ahead with the derivative. So I'm going to bring the 1/2 down in front. There's something already there. So I have to do 3 times 1/2, which is 3/2. And then I have to subtract 1 from the exponent. So 1/2 minus 1 is negative 1/2. Now I'm just going to make this look pretty. So I'm going to flip this down. Alright, that's a perfectly acceptable answer. That's full credit. But it's very nice if you throw it back in a radical form. So if you write it as 2 square root of x, that's really nice. So either of these are correct. All right, let's just try one more of these. I can't quite read this, so let's just pretend that this is a 3. Oh, maybe it's a 5. Okay, so it's 4x to the 2/5. Let's say it's 4x to 2/5. My battery's going, so I hope we make it through this one. All right, you got to bring it upstairs, right? So it's 1/4 x to the negative 2/5, because we take the power rule from the numerator. So I flip this upstairs. All right, so here we go. You're going to bring this down in front. Now you're multiplying 2/5 times negative 1/4. So however you do it. I reduce first myself, but a lot of you I notice don't. So if you don't reduce, it's negative 2 over 20. I mean, you reduce afterward. And then this would reduce to be negative 1/10. I like to cross and reduce first and then multiply. All right, so for the derivative so far, when we bring this times this is negative 1/10. All right, now we have to subtract 1 from the exponent. So you need an LCD because you're doing negative 2/5 minus, if you do LCD, it'd be 5 over 5. So it's negative 7/5. And again, just like I asked before, no negative exponents. Okay, I'm going to leave it like that, but you could certainly write it in its radical form. You would do 5th root x to the 7th under there. All right, gang, I'm going to end this video here with this rule, and then in the next video we'll pick up another rule. I'll catch you. Bye-bye.